Now, if you took a bunch of these solar cells and assembled them together into what we call a solar module or solar panel, you can then power much bigger things, because now you have many cells operating together.
Now, once we have obtained electricity out of the solar cell, we need some means to store it for later use. And this is where the batteries come into play. This is a test site where we generate electricity through photovoltaics.
This is 4 photovoltaic modules hooked together into what we call an array. The sunlight strikes these 4 photovoltaic modules. The power is then routed down through wires inside this conduit. Runs into this box here where there's a control panel and a bank of batteries. The power runs out of the control box through this conduit and into the building here, where it's then distributed to the various conduits. It provides power to these electrical outlets, these lights, this computer, and even a refrigerator. These small solar systems generally just have one small solar photovoltaic panel. They put out at peak power about 50 watts of power. Power is the rate at which you consume or produce energy. If you have a 100-watt light bulb and you use it for 1 hour, you've just consumed 100 watt-hours of energy. The amount of energy used equals the amount of power times the time that you used it. So 100 watts times 1 hour is 100 watt-hours. Now, if you leave that light bulb on for 10 hours, you've now used 1,000 watt-hours, which is the same as a kilowatt-hour, because a kilowatt is 1,000 watts. When you get an electric bill, it has on there how many kilowatt-hours that you used that month, and you pay a price for each one of those kilowatt-hours. If you have a photovoltaic module that is rated at 50 watts. That means over the course of the day you'll have 5 sun hours times 50 watts, which would give you 250 watt-hours of energy out of that panel. Panels come in lots and lots of different sizes. The amount of energy or power that a panel will produce is directly proportional to its size. If you are using a particular type of solar cell in a solar panel, the one that is half a square meter will put out twice as much power as the one that is 1/4 of a square meter. And that's simply just because it has twice as much area and can catch twice as much sunlight. In fact, the amount of energy that a solar panel will put out is directly proportional to its shadow. So if you have a panel and you tilt it a little towards the sun, its shadow will get bigger and it will put out more electricity because it is catching more sunlight.
Basically, the higher the area, the more energy you can generate. Photovoltaics can deliver energy to the cities. We can satisfy any needs for energy demands. I think photovoltaics has a bright future.
Photovoltaics is already happening now. There are many applications where this is the technology of choice. The costs of fossil fuels continue to rise. We're going to run out of things like oil. I see the environment becoming a much greater concern. Solar electricity is going to play a very important role in providing power. It also does not harm the environment.
It's good for mankind, and this is what we are trying to do. I love my work.
You will have that satisfaction of knowing that you're doing something that's helping the world. And I really enjoy that aspect of it.